Oh, threads found. Great. That's fun. Ah. That is new. Didn't expect that. Threads found. What it didn't like. Oh, and doesn't tell you anything. That's fun. Oh, threads, protection history. Thread blocked. Severe. Trojan. Look at that. They're trying to install a Trojan. Possibly yes, possibly not. In that case, I'll not recommend that solution. Ha! Go figure. We'll just go with good old manual installation. We want 64-bit, yes. That'll be funny if that will be a Trojan as well. Okay. And couldn't download, virus detected. What on earth? Let's research that topic, because this is interesting. Google.com, please. Don't switch right now. This is just a VM. NIM, Windows. What is it? Virus detected. And that's from 2022. Okay, I guess I won't be recommending installing NIM on Windows in that case. All right, that makes my video shorter. Oh well. It's funny that they don't even mention that there might be a situation like that. And this is a fresh install of Windows. Too bad. All right, so let's move on. Let's switch back to not the VM. I'll close it all out. We don't need it. Okay, so let's move to installation of Linux. This should go a little bit smoother. Let's get here. I will start the same way. We search for NIM language. That will take us to their front page. Can go install NIM, and this time we use a Unix system. And here, straight away, the recommended way is to install using choose NIM. And all we need to do is the command. This is a command taken from the choose NIM repository. So what we need for that is basically a terminal. Let me just grab a terminal that's connected to the proper thing. There we go. So all we need to do is on our machine, you just paste in the command and run it. I won't agree to the telemetry data at this point. Oh, let's run it as sudo instead. Okay, so no C compiler found. Install GCC using your favorite package manager. Okay, so we do sudo apt install GCC. That should solve our problem. And by the way, this is Ubuntu server. So this is basically straight up Ubuntu, so it should work relatively easily. So now I can run the command. There we go. It's that simple. You make sure you have CCompiler installed. You run the command. And then at the end, we just need to remember that in case of Ubuntu, we need to place the following line in the profile or bash rc file. So I'm gonna copy this thing. And let's do nano.bash rc. I can run .bash rc because I'm already in my home folder. And we can go all the way to the end and simply paste our export. And this will make sure that the binaries of nym are in a appropriate, are accessible from the command line. So to save, we do Control X, and this will ask us if we want to save it, and we press Y to yes, and enter to confirm the name. And now we just need to do source bash rc bash rc. And now, after all that, we can just do nym version. There we go. We have nym compiler version 202 installed. That's all there is to it. At least on Linux, it's easy, and it doesn't raise any thread protection alarms. Alrighty. So now that we have that out of the way, we can get back to our tutorial. Let me just set things up so we're back where we started. Okay. So last time we finished during our live stream, we finished with loops and their exercises. We did all the exercises. And now we can get back to containers. Continue with containers, which should be actually fun for a change. Because containers, well, that's where more advanced, more useful things are starting to happen. So, containers are data types which contain a collection of items and allow us to access those elements. Typically, a container is also iterable, meaning that we can use them the same way we used strings in the loops chapter. For example, a grocery list is a container of items we want to buy. And a list of primes is a container of numbers. Written in pseudocode would have the grocery list. That is a list of, for example, ham, eggs, bread, apples. And for primes, we just have a list of numbers. That's pretty much it. So, there are many types of containers. Therefore, we can start with arrays. An array is the simplest container type. Arrays are homogeneous. An example, what it means, all elements in an array must have the same type. Arrays are also a constant size, meaning that the amount of elements, or rather the amount of possible elements, must be known at compile time. This means that we call arrays a homogeneous container of a constant length. The array type is declared using the keyword array. Then we have our square brackets, and inside we have length and type, where length is the total capacity of the array, number of elements it can fit. And type is a type of all its elements. The declaration can be omitted if both length and type can be inferred from the past elements. The elements of an array are enclosed inside of square brackets. So let's see. We declare a variable, a. And we define that the type of that variable a is an array of 3 elements that are of type integer. So this array will be able to contain only up to 3 elements, up to 3 numbers, basically. And then we define assign it the first value. In this case, it will be 5, 7, 9, and it's all within brackets. It's not simple. I like that you don't have to use any other special characters. Dealing with an array, use just brackets. With B, we have basically pretty much the same thing because we passed it a piece of code that basically creates an array of 3 integers. The compiler will assume that, oh, we mean array of 3 integers. So if we provide the values at compile time, it will be just like that. Yeah, although correct, there is no need to declare it like an array A. So yeah, basically if we know that this is all the only thing we'll be holding in, there's no point doing that. Too much work. With the next one, with the C equals, and we have just brackets, nothing inside, apparently that throws an error. Neither the length nor the type of the elements can be inferred from this kind of declaration. This produces an error. Exactly, because we tell it that it's an array, but the compiler needs to know how much memory to reserve, and therefore, it doesn't know what kind of type it's going to be holding, nor how many elements there are. In our human brain, we think, oh, it's 0, so to do 0, but at that point, what's the point? Compiler doesn't like it. And let's look at D. We declare an array of 7 elements that are strings. So basically 7 strings we can fit in there. Number D. Number 3. The correct way to declare an empty array, which will be filled later, is to give its length and type. So we gave it length of 7 and type of string, without providing the values of its element. Array D can contain 7 strings. So we basically create an array that can contain 7 elements. There just isn't something at this point in it. Okay. Since the length of an array has to be known at compile time, this will not work. So we declare a constant m, which is number 3. Then we create a variable n, which contains 5. So if we declare an array A that has length of m, which is a constant, which is known at compile time, this will work. But here in B, we try to use n as length. And even though it's right here in the code, this is declared as let, which means that this code is basically isn't running at compilation time. It's only happening at runtime. Therefore, this will throw an error. Exactly. This produces an error because n is declared using let. Its value is not known at compile time. We can only use values declared with const as length parameter for an array initialization. Okay, so sounds like arrays are very static and efficient, because compiler knows as much as you can about what is being held inside. Okay, so arrays, we need to use the word array and square brackets. All right, so let's move on to sequences. Sequences are containers similar to arrays, but their length doesn't have to be known at compile time, and it can change during runtime. We declare only the type that is contained, type of the contained elements with the seq for sequence. Again, just normal brackets, square brackets, and the type inside. Sequences are also homogeneous, as in every element of a sequence has to be of the same type. The elements of a sequence are enclosed between at and this square brackets. Okay. So here we declare a variable e1, which is a type of, its type is sequence of integers. And we create, looks like an empty one. The type of an empty sequence must be declared. Okay, so you can have an empty sequence. You just need to make sure that you define the type, as in what is being held inside. And next example is where we create a variable f, and we, instead of specifying type, we instantly assign a value. In this case, that at will say that it's a sequence, and we have 2 strings inside. And the type of a non-empty sequence can be inferred. In this case, it's a sequence containing strings. Perfect. Less work for us, less writing. Compiler is smart. Okay, that's straightforward. Another way to initialize an empty sequence is also to call the new sequence procedure. New seq. We'll look more at procedure calls in the next chapter. But for now, just know that it's also a possibility. So we can declare a variable e as a new sequence of type int, and I guess this is just calling it procedure. Procedure is like a method or function, so that's pretty straightforward. Providing the type parameter inside the square brackets allows the procedure to know that it shall return a sequence of a certain type. A frequent error is omission of the final parentheses, which must be included. Yeah, I presume that if we would omit them, we would just put the whole function inside a variable, and that wouldn't be very useful, at least in that case. Alrighty. So we can add new elements to a sequence with the add function, similar to how we did with strings. For this to work, the sequence must be mutable, defined as var, and the elements we're adding must be of the same type as the elements in the sequence. Oh, I really like it. When you think of some other programming languages, for example, that would be in, let's say, when you create a list of elements in C#, or when you create an array in JavaScript, even if you declare it as const, it only means that the pointer that points at the value at the whole list can change. You can reassign the whole value, but you could still add elements to it. You need to freeze it in JavaScript world. So here, somehow, the whole thing is being protected with those separate tuples declarations. So we declare a variable, so those sequences can change. We declare a sequence G that has that contains 2 characters, X and Y. Then we have another sequence that contains also characters, this time 3 of them. So what we can do is call g.add, and we add a z character, adding a new element of the same type character. And we can print it out, and this should print x, y, z, at least a sequence. We'll look at it in a second. And then we have h.add, and we can add g. So we get that sequence, and looks like we can add the whole other sequence to it. And because if you would try to do it in JavaScript, you would end up with an array that holds that number 1, number 2, number 3, and then will be inside of it another separate little list. But because it was said that sequences are homogeneous. English is hard. Homogeneous. That means that compiler knows that it's not possible to put a list inside of a list here. It expects those values, so if we added that G, it checks, is G also of type character? And okay, we're going to put, concatenate them together. So adding another sequence containing the same type. And here we have the results. When we just added Z to G, we ended up with this sequence. And the next sequence, we have the 1, 2, 3, and the contents of the other one. So we suddenly have 6 elements here. I like it. Very simple, very clear. In C# you need to do add range or some other shenanigans. This is simple. I like it. Trying to pass different types to an existing sequence will produce an error. So we have a sequence of integers, and we try to add a float. Of course, we'll throw an error. And if we'll take G, which from here is the sequence of characters, and we try to add a sequence of numbers, it will also be unhappy and just ignore it. Okay, makes sense. Alrighty. Let's continue. Yeah, trying add to float to int is bad, and trying sequence of int to sequence of characters is also bad. Since sequences can vary in length, we need a way to get their length. For this, we can use the len function. Okay, so just like we can call add, we can call the sequence.len, the return length. So this will be 3. And here we added another character, so now another number, so the length suddenly should return 4. And yeah, there we go. Cool. Simple. .len. Indexing and slicing. Indexing allows us to get a specific element from the container by its index. Think of the index as a position inside of the container. Nim, like many other programming languages, has zero-based indexing, meaning that the first element in a container has the index 0, the second has the index 1, etc. If we want to index from the back, this is done by using the, whatever that symbol is named, prefix. The last element, first from the back, has the index of whatever 1. Okay, I like it. I guess it's on purpose that they didn't go with negative numbers. I recall some languages allow you to put negative numbers in an index, and that will start counting from the back. But then I can see problems where there was some miscalculations, and suddenly it takes in random element from the list because of something. So, okay, this is explicit. The syntax for indexing is you get the container, and in square brackets, you put an index. So, for example, we have the an array, because there's no @ symbol before this. We take an array of 5 elements that are all characters. So if we'll do echo j, which is the number of the name of the array, we'll say we want the element 1. So because now we know that it's 0 base, it will be really the second character. So it should return B. 0 base indexing. The element at index 1 is B. Exactly. And if we'll go echo j, and we do this thing 1, this should return last element. Getting the last element. There we go. That's simple. Okay. Pretty much everything clean so far. And I presume, let's try it. Let's grab this code. Let's put it in VS Code. Okay. We'll save it. We run it. And there we go. B and E. So what if we're gonna change it into a sequence instead? We'll put an @ symbol here. save it. We see that already. VS Code detected it's a sequence. Okay, so we don't need to do anything special to when we're using an array or sequence. We should be able to run it. I'll still get the same result. Great. Okay. That got my curiosity, and this will be 2. Should get D instead. Oops, wrong shortcut. Yes, D, because we get the second from the back. So this is first, this is second. Okay. Cool. Okay. So let's move on. Slicing allows us to get a series of elements with one call. It uses the same syntax as ranges, introduced in the for loop section. We use the start-stop syntax. Both ends are included in the slice. Using start-stop with the less than syntax, the stop index is not included in the slice. Okay. And the syntax slicing is, again, container, and in the square brackets, we just put that range. Easy enough. So if we'll call echo j, which were those characters, from 0 to 3. So we'll have a character 0, character 1, 2, and character 3. So that should be 4 characters. There we go. A, B, C, D. While if we'll call with this little thing, we will have 0, 1, 2, and 3 will be omitted. There we go. Okay, makes sense. I like it, and this way, this looks like it returns a sequence. Oh, that's very interesting. Both indexing and slicing can be used to assign new values to the existing mutable containers and strings. To the existing mutable... we'll get there in a second. Let me just check something, because as you remember, J was an array. When we got a range, we got a sequence. I think I know why. Let's try this. Let's try something. So let's keep that sequence J, and we'll say that we're gonna echo from 0 to 3, right? Should be A, B, C, D. We save it, we run it. There we go. It returned a sequence of A, B, C, D. But we started with a sequence. What when we get it back to an array? Save it. Run it. We also got a sequence. Okay. So what that suggests to me is that we have the result of slicing, getting a whole range of characters. It doesn't return an array because it's hard to predict what the actual size is. As in, I presume that I can, if I'll do constant max equals 3 and put from 0 to max, it's still all within the compiler. So if I'll run it, in theory, I could expect an array, but no, not in this case. So that means I should be able to just make a variable. Something that's not compile time. That's something that's not known during compile time. So let's run it. Yeah, it still allows me. I'll say 2, run it. Yes. Okay, so we know that we can calculate those slices, the ranges, during runtime, and no matter if it was known at compilation time or during runtime, we know that we have that. We'll get a sequence returned. So they just said that slicing allows us to get a series of elements with one call. Wait, here. Both indexing and slicing can be used to assign new values to the existing mutable containers and strings. That sounds very interesting. So let's see. We have variable k, and it's an array. So it's known during compilation time. Array of 5 elements, and these are all integers. Then we gotta create a sequence of 3 characters. And then we have a variable, which is a string. And you can think about a string as basically a sequence of characters, right? This will be a string PWR. It's just written as separate characters. Well, here it's just nice and handy because we use that specific sequence of characters so often that, we call them strings. So we can iterate from 0 to 4. So be our index. We take k as our array, and we get the specific value and specific index, as in, go through each element, and we can assign it a value. In this case, it'll be from 0. So it'll be first element will be 0, second will be 7, next will be 14, and so on. And this should assign all the elements. Remember that this is length, but because arrays are indexed from 0, we have 5 elements. Element 0, 1, 2, 3, and 4. We don't have 5 because with 5 that'll be 6 elements. And when we print it out, it should print out a nice thing. So let's see. There you go. Just an array. So we start over an array, and we have an array. We just assigned those values because here we created empty, so there were no values. Okay. Array of length 5 has indexes from 0 to 4. We will assign the value to each element of the array. Great. Now, let's go to L, to our sequence. We take L, index 1, which will be W, and we assign the letter Q. So we should echo the sequence of PQR, sorry. Yes, PQR. Changing the second element, index 1, of a sequence. Great. And then we have our string. It looks like we can use the same way of accessing elements of a string, just like sequences and arrays. This way, we take characters from 8 to 9, so which is 8 and 9, and we assign the letters BA. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So this is the 8 and 9. So it should be Tom and Barry. There we go, Tom and Barry. Changing characters of a string at indexes 0 and 1. Let me try something, because I already have questions, especially with that last one. So we've got that string, and we replaced element 8 and 9 with BA. So we took 2 characters and replaced them with 2 characters. What if I'm going to add 1 extra character? Save it and run it. Look at that. We replaced 2 characters with 3 characters. What if I'm going to select the whole thing? It was 8, 9, 10, 11, 12. So we get from 8 to 12. We'll select the whole Jerry. And we'll say Ben, which would be less characters. Save. Run. There we go, Tom and Ben. So when it comes to sequences, we can replace it with different lengths, at least when it comes to strings. What about sequences? Can I take our sequence L and let's say we'll replace character from 1 to 2, which will be W and R. What is going on? With something like we need to give it 2 characters, right? So how do we do it? We need to add another sequence to it? Ah, that's where it becomes less simple. O and D. And when I run it, what will happen when I run it? It replaced it. Pod. It took the W and R and replaced it with OD. Can I add another character? Can I elongate it? Save. Run. Yes, we've got pods. Can I make it shorter? Yes, we can make it shorter too. That is awesome. Okay, so we can use ranges to make something shorter or longer. What if I will just take that, we'll take that index 1, the W, and we assign it with O, and then another O. Can I do that? We're taking now sequence of characters for what expected character. Okay, so if we're assigning a single element, it's problematic. So could I do from 1 to 1? Run it. There we go. So we need to use basically a range to be able to do something else than assign a single value. We can replace something more complex with that. Okay, makes sense. Cool. Oh, that already gets me thinking. So what if I'll have a... Can I do something like let, and we'll call it range. Oh, that's a word. Selection is from 1 to 2. Can I assign it as a value? Variable? Yes. It's just not used. Okay. So can I put it here? Selection. Save. Yes, I can. So what if I'll make the select, let's call it selection range. I will create a new variable. Let's say that will be variable selection, and that will hold the actual thing. So say equals, and we do that with L selection range. So now our selection should be of type, should be basically a little sequence from 1 to 2, which will be WR. So we have some kind of code that calculates what our range should be. We have different code that extracts that sequence, and then I guess in a separate step I can say that, hey, selection, and let's say the first character of that selection is or let's say that first character gets replaced with the sequence OO, right? So this should suddenly turn from WR to OOR. And now I should be able to say, hey, take that initial sequence L and that selection range, we want to replace it with what we calculated, which is a selection. We modified it. And that should return L. We can get rid of all the other ones. So that should have the same effect. I just want to make sure that actually we can do that in those separate little steps, because that means that we would be able to take those slices as little sequences, pass them around, do modifications on them, and put them back. And I'd say that would be a useful thing. So let's run it. There it goes. It works. That's very exciting. Very, very exciting. At least for me, it's exciting. All right. So, continuing. Everything works here. Okay. So, continuing with our tutorial. We finished with sequences. Let's go over tuples. Both of the containers we've seen so far have been homogeneous. Tuples, on the other hand, contain heterogeneous data. As in, elements of a tuple can be of different types. Similar to arrays, tuples have fixed size. So, the elements of a tuple are enclosed inside of parentheses. So here we created a variable, n, and we created tuple, just parentheses, that's what this was, it's a tuple, of 3 values. First one is a string, second one is a number, and the third one is a character. Tuples can contain fields of different types, in this case string, int, and char. And when we print it out, we get this thing. We just don't get just banana 2 and C. We get field 0, field 1, and field 2. We can also name each field in a tuple to distinguish them. This can be used for accessing the elements of the tuple instead of indexing. Oh, before we get there, they said instead of indexing. So we'll take this thing. Let's see if our assumptions are correct. And we'll get back to Visual Studio. So we have that tuple n. When we echo it, we just get our classic banana. Okay, that makes sense. So, oh, look at that. We actually didn't get the field, the thing that they got. We didn't get this whole thing. We just got this. That's interesting. But what I'm trying to understand is that we can echo 0, and this should access the element 0 of this, because they call it a container, right? Just like sequence. If we'll do 1, we should get number 2. So let's try 1. We got number 2. Perfect. Okay, so they just act as those. But can I do for whatever value in n echo value? Can I do that? Type mismatch. Expected 1, iterator. Okay, so I guess we cannot iterate over the tuple. Okay, makes sense, because at this point it will be, compiler wouldn't be sure what the value is. Alrighty. So we can also name each field in a tuple to distinguish them. So we can specify that the variable O, we create a tuple because we have parentheses, and we say name is banana, weight is 2, and rating is C. So instead of accessing in this case, assigning the index 1, which will be, I presume, weight, right? Change the value of the field by using the field's index. We could do o.name, so we had dot notation for accessing those elements now that they're named. No square brackets, no weird shenanigans like in JavaScript. This is more like in a JavaScript object where we can just do .name. And a value, Apple. Changing the value of a field by using the field's name. And look how they made those examples. Whenever they were assigning weight, they assigned it also to integer, the same type. When they took name, they assigned it as string, just like here. So I presume that we cannot change the type of the specific field. Let's try that. Let's grab it. All right, we'll save it. It's all good. We'll run it. We have, yep, exactly what I expect. But what if instead of Apple, I want to assign 123? Save it. There it is. Got an integer, but expected a string. So the types, they stay the same. Okay, makes sense. Makes them behave like tuples and all the statically typed languages that I know of. Okay, and we already got 2 exercises. Wow, that was fast. Or maybe not. Took 53 minutes. So maybe not that fast, but hey, there's something. Okay, doesn't look like we have a lot of viewers today. I guess it's because it's a live stream topic. That's first thing. Not a lot of people watch live stream of programming. And it's Friday, everyone's partying, so not a good time to stream. But I'm not a party person, so hey, I like programming. That's more fun than parties. Okay, exercise number 1. Create an empty array which can contain 10 integers. Fill that array with numbers. So it'll be basically whatever times 10. Print only the elements of that array that are in odd indices. And multiply elements on even indices by 5. Print the modified array. Okay, so we want the modified array, so we know that when we create it, it will be a variable. It won't be a let or something else. And this will also allow us to check if really it's that strict about following with what is a let, what is a var, what is const. So we do var, and let's call it numbers. Okay. I'll say that it's of type array. It will contain 10 integers. And we have that defined, okay? Next, fill that array with numbers. 10, 20, 100. Yeah, they give us a hand use loops, so we should do 4, and we want a number that we want to add. Okay, let's continue. For number in, and I think there was count up, right? Count up. We want to do from 10 to 100 with increases of 10 or something like that, I recall. Our language server died, so I guess we don't have hints, but we'll see. And now it will be like, okay, how do we assign those to the numbers? Because usually we need to do numbers. It's an array, so we need this index, right? And they say that's the number. But the for loops we learn, we can just say, hey, our index comma number, and the first thing will be the index, so it'll be 0, 1, 2, 3, and this should be the number. So this should work in theory. So let's just do echo numbers. Let's actually do it once again. Oh, doesn't like it. Wrong number of variables. Does it need to be in parentheses? Nope. Okay. Then I have just I. Okay, that's new. I didn't expect that to happen. So let's go back to our tutorial and see what we missed. We're in loops, for loops, right? We go to from here to here. We had count up and count down. And we get the word. And we also need to have iteration counter starting from 0. We can achieve that by using for, counter variable, loop variable, and an iterator. Very practical. So that's what we're doing. For something, index, comma, letter, in Word. Okay, I think I see what's going on. So this isn't happy. What if I'm gonna do, instead of count up, I'll just do from 0 to 10, save it. Still not happy. Why? Wrong number of variables. I would say hello, save. Now it can go through that. Okay. There's something weird going on here. We can get index when running through a string, but not when we're going through a range or the results of a count up. So what if I'm gonna, because the very quick way to do that would be, okay, screw the index. I'll just do the index, right? We're gonna say we go from 0 to 10. I mean, we need to skip the 10th number, but we know that will be 10 elements. And then the number will be basically the index plus 1 times 10. We'll save that. We should get a result, right? So let's run it. We started with an array of zeros, so I guess it defined default values, and for integer, the default value is basically a 0. And then we assign those values that we wanted. So this is all good in this case. The code is simple. But what if this whole calculation here is a little bit more complicated? Maybe it's not just, the index times 10. Maybe you want to go over something more complex. So what if instead we're going to do something like values, and we'll get that count up that we wanted. I presume this will return a sequence. So let's do echo values. And we'll do let, because we won't be changing it, right? And let symbol requires initialization. I thought that's what I'm doing here. Expression has no type or is ambiguous. Huh. What is going on here? Let me just try to run it and see if this is just some stuff. Nope. Attempting to call routine count up. It's found from A, B, and then step. Iterator declared in there. So it's an iterator. But it doesn't really work, right? There's no type. Type integer? Save? Ah, look at that. That worked. So this is something that I would expect because I know about the concept of generics. And we saw that we were calling some that new sequence procedure by specifying integers. So I figured, hey, this might be the same thing. And what is values now? It didn't run. Let's clear that and try to run it again. Error, internal error, proc has no result symbol. No, okay. I see. So I guess this whole count up is some kind of internal shortcut that can be used only within the for loop. So we can't do anything fancy. Okay. I see. Too bad. Because I hope that we will be able to, do something fancy. But let's try to do it different way. So let's say that we get a variable, sure, values. And this will be an empty sequence. But we need to say that it's a sequence of integers, right? We said it's empty sequence. So I guess we can just skip that. All right. And what we can do is basically do the for loop. And we go, sure, index in, and we go from 1 to 10. All right. And therefore we can say values dot add. So we will add that index times 10. And what we should end up here is basically, let me echo values. Let's get rid of this echo to not do that. So first thing we should see is our values that we want to have. And what just happened? Values don't like being specified as a type mismatch. Oh, right. When we specify type, we need to say it's a sequence. There you go. So now this should be basically numbers 10, 20, up to 100. So when we run it, not this shortcut, that shortcut. We have a sequence of those numbers, right? But we need to add them to, so let's pretend that this is some complex situation where we created, a bunch of values. We got it from somewhere. It could be anything, right? Could be random, could be read from a file or something. We just have values that we want to add to set to the numbers. So what we could do is for index, comma value in values. Can we do that? Yes, we can. So we can take a sequence, and when we iterate with a for loop, if we iterate over the values, we can get both index and value. Therefore, we can say index is the value. Save it, and Run it. Yes, so we assigned it properly now. Okay, that works. But what if those values might be longer or something? What if there's more? So let's say that make a sequence from 1 to 20, right? And we'll do echo, we'll do values, and we print values. At the end will be the numbers. Numbers. Now when we just print it quickly, what do we do? Oh, now it's unhappy because our values are from all the way that much. While we're iterating over them, suddenly we got to the point where index is larger than what numbers can contain. Unhandled exception. Index 10 is not in 0 to 9 that was in here. Because numbers is only from 0 to 9. We just find there's 10 of them. Too bad it doesn't say a little bit more that, hey, this is, I don't know, index out of bounds of variable numbers. That would be a little bit more helpful. But oh well, I guess it's something you can get used to. Okay, so what if instead of doing this, we'll do 4 and it'll be the number in numbers. Can we do that? When we iterate over the numbers and we do number is 5? Is that possible? No, we can't do that. Okay, number is just we can't assign like that. Okay, makes sense. So what we can do here is index, comma number, and then we go numbers dot index is 5. So now we'll be able to assign all the elements of the array, right? So when we run it, we assign those. Cool. So now to go a little bit further, to make it a little bit more error prone, we can say if index is larger or equal to the length of two values, the length, right? Because we could get length of the sequence. So if we have a situation where the numbers array has more elements than values, we can basically say break, because we don't have more numbers to assign. And this way we protect ourselves from a situation where, let's say, our values are only, I know we have 3 values in there, right? Let me clear that and we run it. So our values is 10, 20, 30. And if we want to assign them over numbers, when we are iterating over numbers, we'll suddenly go with like 1, 2, 3, and more. So in this case, I only assigned first 3 values because then we didn't have more. In this case, we of course need to say that the number, whatever's under that index numbers, will be values in the same index. I know that I'm going way off the track for that exercise, but I'm exploring. I'm doing what I like in this case. So yeah, this way we protect against this situation where there are more numbers than the values to assign. And of course, if we have the opposite situation where we have a lot of values, this iterates only over what we have in numbers, so we will never exceed it. So now when we run this, even though we have tons of values, we'll just go over whatever's here and we have the result that we want. Okay, so that was like 30 ways to solve this problem. We can go on to the next exercise. We're in containers exercises. Number 2, let's just copy it and paste here so that we can work at it as we're reading it. Okay, let's get rid of this code. We don't need it anymore. Now, redo the callouts conjecture exercise, but this time instead of printing each step, add it to a sequence. Pick a starting number. Interesting choices, among others, are 9, 19, 25, 27. Create a sequence whose only member is that starting number. Using the same logic as before, keep adding elements to the sequence until you reach 1. Print the length of the sequence and the sequence itself. Okay, so before I go and check the rules for how to create a sequence, we want to have a sequence that we add those numbers to. So let's declare it var, and this will be the whatever result, right? And this will be a new sequence where we put our starting number. So let's also do constant starting number, and we do 9. Okay, so we have our sequence that contains just the starting number, and then what we'll need to do is there'll be loop to add elements. Okay, and after we add all the elements, when we reach the 1 finally, we need to print the length of the sequence. So we'll do echo, we'll do result length, and we'll do the result.len. This should give us the length. And then we print the sequence itself. For now, let's just do echo, and then it will be results. And we'll print just the results. I assume that nim will print it however it wants, but I think we'll be able to do it like with the things that we learned so far in the tutorial. We'll be able to, get to the point where we print them out in a little bit more manner. Like, we started with 9, and we have this nice arrow and do something and this and something. I'm sure there are some whatever built-in functions just for that, but we'll build it our way. Alrighty. So in an earlier tutorial, we had probably in loops, we had an exercise callouts conjecture. So first pick a number. We already did that. If it's odd, multiply it by 3 and add 1. If it's even, divide it by 2. Repeat until you arrive at 1. So let's copy it, and we'll just have it here. So okay, so we can do a while loop, right? And we can check while the result and the last element, of our results isn't 1, we'll do our thing. So if it's odd, multiply it by 3. So let's just do let odd equals again, we're operating on the last number, right? So let's say that the let last number is the result, and we take the last entry there. So let's say is odd will be last number mod 2 equals, if it's odd, that means it won't be divisible by 2, so the remainder will be 1. And if is odd, multiply it by 3 and add 1. So that means that, we need to already start storing the next number. So let's do variable because it will be changing next number. And that'll be our integer. Nothing crazy here, right? But we can take advantage of the fact that, right now we said it's an integer. We might be changing into something completely different at some point. So we can kind of steal the type from here by saying that the next number is basically the last number, right? Because this will suddenly figure out, hey, so this is an integer, and this will be, if we'll change it into some different type in the future, a float or something, it will make more of our code work on its own. All right, so next, if it's odd, we basically do the next number equals next number times 3 and plus 1. And again, I'll just add this parentheses just to make things explicitly clear. So if it's not odd, right, else, we did that. If it's even, divided by 2. So we do next number equals next number divided by 2. And again, we'll use division here because we're operating on integers. So we need to stay within integers. And repeat this procedure until you arrive at 1, which is this check here. So what we need to do is after we calculated the next number, we need to add it to our results. Result.add, and we add our next number. And this should basically take care of our sequence, and we can print it out. So let's try to run it and see. Oh, it already doesn't let us. Expected. Oh, of course, we need the colon here. Save and run. We've got results length. We've got 9, 28, and so on until we arrived at 1. Perfect. Worked the first time. It's a good feeling, especially in a language that you're just starting to learn. Cool. So I'll assume this is understandable, although I want to try one thing. Because we created this variable here. We just assigned it some kind of number, and then if this, we set it to something else, we set it to something. So we have that repeated thing that in both cases, no matter what case, we just assign it something calculated. So what if I'll say that equals, and we do if is odd, it will be the value of the, instead of next number, it will be just last number, because it's the same, right? Last number times 3 plus 1. And then we do else, and we have last number divided by 2. Save. And that should work because this is the equivalent of the ternary expression. And this way we just remove several lines because it's, this algorithm is so simple. Okay, let's go a little bit more extreme. We just take this, put it here, and that should be it, right? Save. So this is starting to look very strange because we add, and inside of parentheses, we have this if, else. But hey, it compiles. Let's push it a little further. We had this last number here, and we calculate is odd, but we use it only here. Let's put it here. Bam. Oh, this is getting real ugly. Okay, can we push it more? Not really, because this last number is used everywhere. It would be pointless to just access it 3 times. Okay, sure. Let's run it. Still completes the same way. Awesome. So now what we wanted to do is instead of printing it as literally a sequence, this is nim printing for us, we want to print it in a nicer way. So format as whatever, 1 goes to 2 goes to 3. So we can do that by creating a string, right? So let's do variable, because strings are mutable, we can just keep adding to them. This will be the result string, right? And we define it, right? This is an empty string. And then we can do for result value in result. So iterate over all the entries. And we'll just keep going, right? Yeah, I'll fix one problem when we get to it. So let's start it. The first thing that we're doing is basically at some point we need to go to result string dot add, and it will be we add the actual result value, right? We'll add it there. Although I don't know, we'll be probably unhappy about something. Because one is string, add result string result value. Yeah, I guess it doesn't like the fact that we're trying to add an integer here. So let's just, I'll cheat a little bit. And I know that if I'll add $sign in front of the value, it should turn into a string. Okay, that works. Good. So if we'll do that, we'll just end up with something real ugly. So we'll have results, and at the end we'll do pretty results. And this will be the result string. So we can compare. So if we're gonna run it, we see that it just added everything together with no space in between, nothing. So let's do it that way. After we add some element, we also add another thing. Result string dot add, and we'll literally add a string space and this little arrow and space, as in space for next element. So when I save that and run it, okay, that looks better. But we have that situation where I have the arrow at the end. So my solution to that would be, hey, let's move it before, right? So when we run it again, we have that arrow up here. And suddenly what we can do is, hey, how about we take that first element of the array, right? And just put it here instantly. So we don't need to do anything. We'll just say, hey, the first element of array, so it will be result and 0, right? This is the first element. We just assign it initials a value and make sure it's a string. And then instead of iterating over the whole result, we can, again, use the thing that we learned. Instead of starting from 0 to the end, we just do 1 all the way, and let's try to the last element. I hope it works. Let's run it, and looks like it works. Your first element, and then it just continues. That is awesome. Okay, I like that. So we just get rid of this printout, and they suggest the value 19. I wonder what that is going to show. Yeah, just long sequences. Okay. Okay, that was easy. We learned a little bit about how to handle and not handle those things. So let's continue. Rule is 50. Followed the channel. Thank you. Thank you for a follow, but it turns out it's an ad, so no thank you. But hey, thanks for the follow, why not? Okay, continuing. We need to get back to containers, and we have the third and last. Find a number in range from 2 to 100, which will produce the longest callout sequence. For each number in the given range, calculate its callout sequence. If the length of current sequence is longer than previous record, save the current length and the starting number as new record. You can use the tuple, longest length, starting number, or two separate variables. Okay. Print the starting number, which gives the longest sequence and its length. Sure. Let's copy the thing, and we'll be able to reuse our code. So at least that's something. So basically we have a range of numbers, so we'll need to iterate over them. So, oh, I see, this will be real simple. All right. So let's start going in a way that we'll have the starting number, but let's do it this way. We'll do 4 and starting number in, and we have the range from 2 to 100. Okay. And we can indent everything. And our starter number is already declared here. Just get our results. We just do all this stuff. We basically calculate the whole thing, and we have the length, okay? And we don't need formatting it anymore. I'll just put it away from later. So we have we can actually print out for which number what the length is for now. So and we do starting number, the length is, and we have the length of the result. Okay. And if we'll just have a loop like that, we're just gonna loop over all of them. Let's just ignore all that and see what happens when we run it. Okay, for 2 is that, not that, and it just continues. We can see that for 7 it was nice length, etc, etc, etc. Oh, for 27 it's 112 steps. Wow, that's a lot. And it went like that for the whole thing. That is awesome. So we can just iterate over them. So now all we need to do is basically the record. Which will produce the longest. Calculate the callout sequence. We did that. If the length of current sequence is longer than the previous record, yeah. So basically override new record. So longest length and starting number. That's what we need to track. I won't bother with a tuple because it's kind of pointless here. So what we're gonna do is we have a var max length, and we do of course start from 0 and var record starting number, and we start with 0 because whatever. So when we go to the length, right, instead of just printing it, we can say that length is the result len, so we have it as variable, and then we can say if length is larger than the max length, so if it's a record, then we say max length is the new length. And then we also do the record start number is the starting number. And that should be it. And the end, we just say echo the largest, then the starting number. And we do the record starting number. Made a sequence of, and we put the max length and values. This will print it out nicely. Okay, so when we clear it and run it again, we have the starting number 97 made a sequence of 119 characters. Awesome. So that means that we can suddenly lift it up to, I don't know, 10,000, run it, and invalid indentation. What? What happened? Where? Oh, now it worked. Okay. The starting number 6,171 made a sequence of 262 values. Perfect. Easy peasy. So we just finished sequences all the containers. And I'd say this was an interesting chapter. I'm sure there are more different types of containers because, you know, this can't be all really, seriously. But I'm really happy to see tuples because that means that, you know, it's easy to return multiple values from, I guess, procedures. Therefore, you don't need to do shenanigans with references and whatnot. That means that you can probably define them as types and reuse them because you can name some of the values inside tuples. That means you can also use them as little temporary objects instead of, you know, declaring specific type somewhere or whatever. You just do on a go. And in C# that will be an equivalent of a anonymous object. So yeah, I like it. I like the difference between a sequence and an array. They are pretty powerful already on their own. So yeah, let me grab some water and we can continue with procedures. Okay, so procedures. Procedures, or functions, as they are called in some other programming languages, are parts of code that perform a specific task, packaged as a unit. The benefit of grouping code together like this is that we can call these procedures instead of writing all the code over again when we wish to use the procedures code. In some of the previous chapters, we've looked at the callouts conjecture in various different scenarios. By wrapping the callouts conjecture logic into a procedure, we could have called the same code for all the exercises. That's correct. That's where I was itching. Like, oh, I need it. So far, we have used many built-in procedures, such as echo for printing, add for adding elements to a sequence, inc to increase the value of an integer, len to get the length of a container, etc. Now we'll see how to create and use our own procedures. Gosh, I'm actually excited. Some people think it's sick to be excited about something like that. Some of the advantages of using procedures are reducing code duplication, easier to read code as we can name pieces by what they do, and decomposing a complex task into smaller steps, simpler steps. As mentioned in the beginning of this section, procedures are often called functions in other languages, or methods in C# if they live in a class. This is actually a bit of a misnomer if we consider the mathematical definition of a function. Mathematical functions take a set of arguments, like, for example, function takes x and y, where f is a function and x and y are its arguments, and always return the same answer for the same input. Yes, that's basically a function. Programmatic procedures, on the other hand, don't always return the same output for a given input. Sometimes they don't return anything at all. This is because our computer programs can store state in the variables we mentioned earlier, which procedures can read and change. In NIM, the word func is currently reserved to be used as the more mathematically correct kind of function, forcing no side effects. I really like that distinction. I started learning programming. I was probably in 6th grade. I had a great math teacher. She just gave me some sample programs and told, hey, go and figure it out. And I learned programming in Delphi. It's Object Pascal or Delphi Pascal. I don't know. These might be used interchangeably. And there were two concepts. There were functions and procedures. So this sounds very familiar. With functions, I couldn't do any wonky stuff. Actually, with functions, you could do wonky stuff. It's just they return a value while procedures didn't return a value. So, NIM is even better. It's actually either function for mathematical or procedure for, doing things that don't behave like functions. I guess optionally. So let's see, declaring a procedure. Before we can use, as in call our procedure, we need to create it and define what it does. A procedure is declared by using the proc keyword and the procedure name, followed by the input parameter and their type inside the parentheses. And the last part is a colon and the type of the value returned from a procedure, like this. So basically proc, its name, argument and its type, another argument and its type, and colon and return type. Okay. So I call them input parameters. Okay. The body of a procedure is written in the indented block following the declaration, appended with an equals sign. Oh, how funny. So we have procedure, find max, that takes two parameters, which are integers, x and y, and returns another integer, and it's defined as this. Okay. And the return will be here. So, first, declaring procedure called find max, which has two parameters, x and y, and it returns integer type. Then here, to return a value from a procedure, we use the return keyword. Okay. And this is a nice little hint that could confuse some beginner programmers or somebody that's not used to this kind of writing style where indentation matters. Because this line is still indented here and starts here. So this is inside of the procedure, still inside. But the moment you have a line without indentation, I presume if you would have a line, like empty line somewhere with nothing in it, you don't need to bother by those spaces in the beginning. But if you would have something here and it's not indented, that suddenly means, okay, this is out of the procedure. It becomes very familiar very quickly. Alrighty, so we've got that. Let's continue with it. Here we have procedure, echo language rating. And we just provide a language, which is a string. And we don't provide any return value. And we do. So let's see. The echo language rating procedure just echoes the given name. It doesn't return anything. So the return type is not declared. Okay, makes sense. And inside of it, we can have the whole case, if this to that, if this to that. and therefore we don't have any return because we're not returning anything. So this is not always required. I presume this is required when we have something to return, and is not required when we don't return. Let's actually try it. If there are some other crazy cases, like it's usually is with nym. So if we'll put this here, save it, it says, hey, it's declared but not used. Okay, I'm fine with that. What if I'm going to say echo hello instead and not return anything? Save it. It's still fine. So what if, let's just reduce it so it doesn't run so much. So what if here I will just say echo. So look at that. When I press enter, the indentation is already here. Enter, indentation is here. So if I also echo world, the second echo is still a part of this procedure, right? Even though the line 30 has nothing in it, not even a space, but it's completely empty, so it's ignored. And therefore this one has indentation that's part of here. I could probably just do bam, and world is still part of it. So after that, I remove indentation and so do echo, find max, and give it X and Y. I presume that's how you call stuff, right? I mean, I'll give it 10 and 5. Save. So it doesn't complain. It should echo the return value. Because if I'll do let whatever max equal, save it. This is declared but not used, and we do echo max, right? It's fine. Let me just close it and reopen it. I don't know why it's showing those, not showing me stuff anymore. Start VS Code and WSL, that worked. Nym suggest initialized. Oh, now it shows that it's an integer. Okay, but we're not returning anything, so let's run it. It returns 0. How strange. So many other programming languages will be like, hey, you didn't return anything. It's wrong. Just printed hello world. I'm sure we'll learn about it, but it's a strange concept. Okay. So we saw the one where we don't specify the type because we're not returning anything. And here, I need to try it just in case. So we have this one. What if we'll say here, return 50. Save. Okay, now return type declared, so it will be complaining. So it won't be like TypeScript where if you return something, it will assume that it's being returned and, infer that. Here it will just, you didn't specify that you're returning something. Okay. Schmelly arc. Echo is right line. You are not returning data from procedure. Yes. I was just checking that if I'll define a procedure that returns something, I'll give it those echoes and don't specify a return. It still allows me to compile. To be honest, I know why it's happening, but here, because I read a little bit when researching the thing, but for the sake of the tutorial right now, I'm pretending that I don't know why this is happening. We just got a 0 from calling that function. So here we have a situation where we say that we return something and compiler is forcing us that we need to declare the result type, explicitly. If I would say that it returns integer, it'll be fine. Yeah. And if I delete a return, it's still fine, but not the other way. I can't say that, oh, it's not returning anything and return something. So that's good, because that's one annoying thing with TypeScript, that if you as a programmer don't have the habit, or, like maybe your team didn't agree on the fact that you always specify what is the return type. In TypeScript, you would say, hey, void, right? And it looks like void works here too. If you wouldn't do that in TypeScript and return a 50, TypeScript would assume that this actually returns integers, which is, it's good design as what it was designed for, as in you can interchange it with JavaScript, but not a good practice when you actually commit to types. So let's continue, because we're talking a lot about one thing, but hey, we're learning from it too. So normally we're not allowed to change any of the parameters we're given. Doing something like this will throw an error. So we have procedure, change amount, we give it an argument as integer, and we do plus equals, which will basically add 5 to the argument. So this will be unhappy about it. Okay. So for our variable 10, change argument, and will it throw a compilation error or something else? Let's see. Yes, compilation error. Type mismatch, expected 1 off. Either, oh, I see, it says var as it needs to be variable. Okay, so I guess this is a hint what we will just learn. In order for this to work, we need to allow nym and the programmer using our procedure to change the argument by declaring it as a variable. Okay, so there it is. Procedure change argument, and the argument is not just integer, is var integer. So I guess it's a mutable integer, something we can change, and now it shouldn't complain. And here with the change argument, our variable, we should be able to, if we give it here, we should be able to change it. So I'll copy it, paste it, and let's just get rid of those maxes and those echo results and whatnot. It's too much. I'll just comment out this whole thing. So we're just focusing on this. I'll save it. Hey, everything is happy. I'll run it. We've got those 2 values. Even though we're printing out our variable twice, it's changing. What if I will say it's let? Bam. Everywhere compilation errors, because again, this mismatch, one is integer, one is var integer. So let will allow us to assign it here, but won't allow us to change it. So I really like it. It forces on both ends. Very good, very pleasant. So let's move on. This of course means that the name we pass it, the name we pass, it must be declared as a variable as well. Passing in something assigned with const or let will throw an error. Yeah, we just tried it out. Cool. While it is good practice to pass things as arguments, it's also possible to use names declared outside the procedure, both variables and constants. I'm not used to talk so much. Alrighty, so we have variable x, that is 100. We have procedure echo x, and it takes that x, and then it increases it. And we can call it twice, and that will cause it to do things. So echo x, here we access the outside variable. Okay, that makes sense. And we can also update this value since it's declared as variable. All right. So the thing here is that the way I would see it is from two perspectives. At least as a programmer that usually deals with, I deal most with C#. And because of that, I'm used to situations where everything is inside some kind of class, within something. So writing a code like here, just, no indentation is actually strange. Well, in the recent versions of C#, they actually allow it now, which is cool. But, so we have this situation, right? We can access that X. So there is nothing stopping us to say, hey, we have a procedure, whatever, right? Doesn't take arguments, nothing, equals. I presume I can do that. And indent. And then called whatever. Okay? So now we have a procedure in which we declare a variable, in which we declare another procedure and call it. I need to see if it actually works. If it works, I will be very happy. It worked. Awesome. So it's often that you write something within a procedure and then, okay, I declared this little helper, then I can call multiple times, which is great. But the moment you remove those and you have just that, sometimes you might be confused, like, oh, wait, I'm outside of anything. I'm not working within anything. You're still within nym file, so this can be done. And I presume that if we're going to move that behind it, it will complain that, hey, it's not defined here yet because it's reading from top to bottom. Okay, my assumptions were correct. Woo. Okay, getting back here. Calling the procedures. After we have declared a procedure, we can call it. The usual way of calling procedures or functions in many programming languages is to state its name and provide the arguments in the parentheses, like this. So we have the name, and in parentheses, argument 1, 2, and so on. The result from calling a procedure can be stored in a variable. Yeah, so if we want to call our findMax procedure from the above example and save the return value in a variable, we can do that with. We define variables A, B, and C, and each just gets the max value of whichever. And this one even takes, oh, that's cool. This one even takes A and B and searches for larger from those. So that's great. So the result from the function findMax is here named C, and it's called with the results of 2 calls. Exactly. And then I can echo values and have something. So I already kind of did that with, when looking at stuff. So that makes sense. Nym, unlike many other languages, also supports uniform function call syntax, which allows many different ways of calling procedures. This one is a call where the first argument is written before the function name, and the rest of the parameters are stated in parentheses. So argument 1 dot procedure name and argument 2. Oh, that's fun. That is very much fun. Oh, I can already see how to use it. Do we have some code here? What do we have here? That's not a great example. Let's say we have procedure +1, right? That takes, for example, let's do add. X, which is integer, and Y, which is integer, right? And we'll return integer. So we'll basically do return X plus Y, right? A simple addition. So normally we would say echo add X. Add, let's call the X is 100 and for Y is 200. 1. So add X and Y. So that's fine. But what they mean, I can do echo, take X because that's an integer, dot add, and we say Y. That is so cool. Oh wow, I love it. I absolutely love it. So that means I can just do extension methods from C#, my favorite feature of C#. That's great. Okay. We have used this syntax when we were adding elements to an existing sequence. Yeah, sequence.add element. As this makes it more readable and expresses our intent more clearly than writing add this to that. You can also omit the parentheses around the arguments. So procedure name, argument 1, command argument 2. We send the style being used when we call the echo procedure and when calling the length procedure without any arguments. Ah. So I could do also echo add x comma y. Expression echo blah blah. Expected one of first mismatch of position. Oh, because I guess I need to say, oh, let's say result is at xy, right? Nope. Okay, let's see if they show an examples. What am I doing wrong here? Add, right? X and Y. We have X, Y defined. Do I need to specify that it's an integer? No. It doesn't like result. I? Nope. Requires an initialization. I have equals here. What the hell? Okay, something isn't happy about this. Not sure what. Oh, maybe it's only for things that don't return anything. I've seen the style being used when we call this and calling length procedure without any arguments. But the length procedure returns something. So I'm not sure about this situation, why it's not being happy. Why I can't do add this and that. Because it wants commas. These two can also be combined like this, but the syntax, however, is not seen very often. Oh, something dot the procedure name. So I guess we could do echo x dot add y. That works. Echo, so this is apparently a procedure. Nope. It doesn't want to work. Maybe without comma. Nope. Don't know why it doesn't work. That's frustrating. Alrighty. The uniform call syntax allows for more readable chaining of multiple procedures. Procedure plus xy. Oh, that's what I did. And we have that. This is exactly what we just wrote. And then we have multiplication. We'll define A, B, and C. We can do echo A plus B, or this plus that. Same with multiplication. That's good. And then we can do, yes, A plus B, and that will return integer. And because this is an integer, we can call that multi. This. Exactly. So if multiple parameters of the same multiple if multiple parameters are of the same type, we can declare their type in this compact way. Okay, I see. That's what I missed. So we can just do that. In our case, it will be simply specifying it like this, right? And that's it. That's good. Let's maybe rename this from add to plus, right? We save it and we do echo plus xy. Nope, still doesn't work. First, mismatch at position, blah, blah, blah. Okay. This. Totally nothing. Oh, this card. Again, problems. Variable pi is this. Again, this is confusing. Oh well. So I like that. First we add A and B, then the result. Yes, so that's exactly what I explained. So let's continue with the result variable. That's the one thing that we had a question we didn't know, but I secretly knew about it. In nim, every procedure that returns a value has an implicitly declared nim every procedure that returns a value has an implicitly declared and initialized with a default value result variable. The procedure will return the value of its result variable when it reaches the end of its intended block, even with no return statement. So that's the thing that we're confused about, at least I was. Basically, you could do, instead of that, you could do result equals this, and it should still work. So we have procedure find biggest, and we give it a sequence of integers, and it will return a single integer. So the return type is integer. The result variable is initialized with the default value for integer, which is 0. So just that, this little bit, secretly behind the scenes created the result variable. So we can do for number in A, if number is larger than result, that's the thing, we can already read it, even though we didn't write to it yet, because it was initialized with default value of 0. And we can assign it. So that it will go through everything, return the biggest. We can just take a sequence, give it to find biggest, and it will return it, even though there's no return statement. So I find it really nice because it's so common that, you define your result type, and then you need to go and copy this type and create a variable that you'll be operating on. And this just makes the whole thing more concise. And this result thing is already there. So you are forced to have this habit where something named result is an actual result. Because I saw so many times that somewhere in the procedure there's something named result, and then it's not being returned because it's returning something else. Alrighty. So now that this procedure is here to demonstrate the result variable, and it is not 100% correct. If you would pass a sequence containing only negative numbers, this procedure will return 0, which is not contained in the sequence. So yeah, to fix that, you would need to basically do something like this. We go and do, to fix it, would simply go and, hey, you know what? The result is the A and the first element, just to start with something, right? Because we don't have that 0 yet. It's our largest element. So this way, if we'll start with negative 33 and we run it, or like only negative numbers, right? Negative, 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 negative. Without that line, when we run it, we'll get 0 because that was the largest number because it was initially initialized. If we'll just assign the first, initially, it's the first element of an array or whatever sequence, that is gonna work. And bam, and it works. But of course, now we're accessing this first element of a sequence, but if it doesn't exist, so if we get a the length is equals 0, then we need to, return something else. In this case, I don't know, throw an error or something. I don't know. Let's assume that will be minus 999, right? We do return. Because now the difference is that when we assign this result, we can keep assigning it. Only when we get to the end of the procedure or whatever the end is, that's when we're going to return it. But if we're going to say return ahead of time, we know that nothing else is going to get executed. So that's the difference. And that return inside an if statement allows us to basically finish things a bit quicker. So if I'll run it now, it should be still working, right? There you go, -5. But if we'll give it a sequence like this, and we just need to, let's just double click here to insert this, and we'll do nothing inside, and we'll run it, we should get -999 because there was nothing. Father would just get an error. Okay, so done with that tangent. Let's continue the journey. I know I'm going a little bit fast, or maybe for probably most people who know some programming, it's extremely slow, but I'm just trying to do it for myself. And if you're watching and I know learning something, hey, that's awesome. So we did through that. Beware, in older NIM versions, before the NIM 0.19.0, the default value of strings and sequences was nil. And when we would use them as return types, the result variable would need to be initialized as an empty string or as an empty sequence. But that's all time ago, so we don't care. It's just good to know that, back then, this would be problematic. Okay. Inside of a procedure, we can also call other procedures. Obviously. But hey, it's good to point out. So we have is divisible. And inside the filter multiples of 3, we basically, in a for each, if it's divisible by 3, we just add it to the result. If not, we skip it. We don't add it. So, yep, you can call them like that. That's simple. Echo and bam. The third way of calling procedure, as we saw above. Didn't work for me. Don't know why. Okay. Forward declaration. As mentioned in the very beginning of this section, we can declare a procedure without a code block. The reason for this is that we have to declare procedures before we can call them. Doing this will not work. So we'll call echo 5 plus 10, we'll get an error. So we'll throw an error as plus isn't defined yet. Only later we have procedure plus. Yeah, here we define plus, but since it's after we use it, NIM doesn't know about it yet. So I guess nim is the language where it literally goes one by line, did that, and it isn't doing like, for example, JavaScript or C# would do, where they magically take those out initially before even executing any code. So it's good to know. Good to know. It's more like in C and C++ languages, or at least C. I recall it worked like that. And because nim compiles down to C or C++, I guess that's the reason why we do this. The way to get around this is what's called a forward declaration. This is exactly what we have in C and C++. We can declare it here, and then basically copy paste that part and define it here, or like implement it. Here we tell nim that it should consider the plus procedure to exist with this definition. Now we are free to use it. Ooh. Sorry. Now we are free to use it in our code. Yeah, it'll work. And then here we finally implement it. So it must be exactly the same thing as here, or it'll be considered something else. Okay, we got the exercises. And okay, looks like we'll just go through modules and interact with user input. I might be finished. We might finish by 1. That'll be awesome. Okay. Do we have anything with those? No, we don't have this thing that we're doing with those. So good. Create a procedure which will greet a person based on a provided name. Create a sequence of names. Greet each person using the created procedure. Cool. So we're going here. We're building everything. We're starting from scratch. And we will do comment as usual. Create a procedure which will greet a person based on their provided name. Sequence of names and greet each person. So we have the procedure that greets hello name. So we do procedure, greet, and we need to provide a name. So we'll say name, and this will be a string. And I guess we're not returning anything, we're just greeting. So we just define it as echo. So we're using a function within a procedure within a procedure. And we do hello. And we do name. So that should be the first part. Create a sequence of names. So let's do let names. And this will be a sequence. And we'll do Ben, we'll do Schmelly Orc. And let's do John Doe. There we go, 3 names. So greet each person using the created procedure. So we just do for name and names. Greet and name. Will that calling work now? Yes, that will work. Awesome. Length string. That is interesting. So there's concept of landing. Huh. Okay, we'll ignore that because that's probably a way more advanced topic that won't be covered in this tutorial. But good to know. So when we run it, right, we will get hello Ben, hello Schmerok, and hello John Doe. Awesome. Okay, let's continue. Create a procedure, find max 3, which will return the largest of 3 values. Okay. find max3. That is really simple. Bam. So we have procedure, find max3, and we'll take 3 numbers, right? So it'll be x, y, z, and that'll be all integers. I will return that largest, which is integer. So what I will probably do is just define another procedure, find max2, that takes x and y, integer, right, and integer, and this will be easier to write. So if x is larger than y, return x. If not, return y. And we can probably just do return if x, y, it'll be x, else y. And we've got that very simple declaration. Okay, so find max will be basically find max 2 of x, y. And we'll just wrap another find max2, and it'll be z. And this way we'll calculate maximum of those two, and then maximum of that, and we'll just do return. And that should be it. So let's test it. Echo find max3, and we'll give it 50, 14, 15, and negative 10. So it should return 15. Let's run it. I've got 15. Okay, that was simple. I'll ask for some fun play. Okay, points in 2D plane can be represented as a tuple, x and y that are float. Write a procedure which will receive 2 points and return a new point, which is a sum of those 2 points. Add x's and y's separately. This will be nicer if instead of calling them points, they will be called vectors, and adding would make a little bit more sense, but okay. Right, procedure, new point. Okay. Write a procedure which will receive 2 points and return a new point. So we do procedure, and we will call it add points, right? And then will be point A will be of type tuple, which is x, y. Oh, we actually have to type tuple x, y float. That's how we define them. B will be tuple x, y float. And this will return another tuple of x, y float equals, and this is fine, it's just not used. Okay, so we know that we can define a type tuple like this, which is awesome. So we need to add them. Okay, so we can do result dot x, right? Because we created this tuple, it should create one of x and y, which both are floats, is a.x plus b.x. And then result y is a.y plus b.y. And because this is a result that we use here, it will be automatically returned. And because of that, we can just test it. So echo add points, and the first one will be x is 15, y is 20. Then the second one will be x is 9.5, while y is negative 0.12. And that should be it, but it isn't happy. Tap mismatch. Let's take a look at the tutorial, how they defined it. For containers tuples. When we're defining them, just with a colon instead of equal sign. Okay, let's do this. Bam. Save. Better. Because it wants floats, so I guess we need to say comma 0 and comma 0. I guess Nim isn't that smart to figure that part out. And there we go. 20 plus negative this will be good, and this and that, it's good. Works. Okay. And I think I recall that in the first stream we were going through the what do you call them? We're going through the examples from the front page, and I think you could do something like type and make it like, let's say point. I don't know, it was equals or something, and it'll be tuple xy float. Yes, that works. It's just not used. So everywhere we call this thing, just do that. Save. It works. Isn't that awesome? I like it because it's really simple. You use that everywhere and just, hey, this is that. That's it. Very pleasant so far. Okay. So we were going through exercises, and we have last exercise here. Create two procedures, tick and tock, which echo out the words tick and tock. Have a global variable to keep track of how many times they have run, and run one from the other until the counter reaches 20. The expected output is to get lines with tick and tock alternating 20 times. Use for declarations. Okay, yeah, because we need to call one from another and back and forth, and it wouldn't be possible to do it without it. Okay. So let's get back here. Let's paste it in here and we'll do it. This sounds complicated, but I think it's really simple. How can I disable the minimap? There we go. I don't like it. Okay, so we have tick and tock. So we have procedure tick, and it just echo tick. And then we have another one, which will be tock. There we go. And the idea is that a global variable to keep track of how many times they have run. So we can just do it here, variable, counter. Let's say 0, they haven't run yet. So we can make it like we learned that counter. We can just do increase the counter, and here increment the counter. That's awesome. Okay, and random from one another. Yeah. The expected result is to get lines of tick and talk alternating 20 times. So I guess the idea is that we call tick, and that should be it. So we know that tick needs to call talk, while talk needs to call tick. Okay? We'll ignore the fact that they're just not upset about it right now. But basically, if counter is equal 20, return. And we return nothing, which will just make it stop. The same goes here, but we need to make sure we increase the counter. So, oh, we already did. Okay. So that should be it. The only thing is that tick cannot call talk because it doesn't exist yet. So we should use that for declaration where you say procedure talk, and it just exists. And that should be it. Let's see if it actually does it 20 times. Oh, those exercises are simple. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Well, let's just echo counter. And we just did the same thing here. Better than me counting it manually. 1 to 20. There we go. That's it. That's our code. No more needed. I like how simple those little things are. You don't need to go deep. Yet it compiles to C and C++, and you have good performance. So that's absolutely awesome. Okie dokie. So we went through all that, test all procedures by calling them with different parameters. We kind of did that, so I guess that's good enough. No. Something going on in the chat, nothing going on in the chat. Okay. Still got half an hour. Let's go through modules. So far, we have used the functionality which is available and by default every time we start a new nim file. This can be extended with modules, which give more functionality for some specific topic. Some of the most used nim modules are string utilities, additional functionality when dealing with strings. Sequence utilities, additional functionality for sequences. Math, for mathematical functions. Yeah, logarithms, square roots, trigonometry. And times, measure and deal with time. Awesome. So basically a standard library, right? But there are many more, both in what's called the standard library and in the Nimble package manager. The standard library, if we'll take a peek, we can scroll in and there's each is a link to a library or whatever we call it, module, which is basically a lot of code. So lots of functionality. That's awesome. And the Nimble package manager is basically all the other packages the community wrote. And hopefully soon enough in the series of streams, we'll be writing our own package or module that will be available for everyone to use. So very exciting. Importing a module. If we want to import a module and all of its functionality, all we have to do is put import module name in our file. Okay, simple. This is commonly done at the top of files so we can easily see what our code uses. Now I'll put stress commonly because we already saw in some examples that you can put it somewhere in the middle of the code. That'll be fine. Okay, so we have import string utils. You get two variables, my string with white space, exclamation mark. So we could do echo split. Using split from string utils modules, it splits the string in a sequence of words. Perfect. That's simple. You don't need to write your own. So I guess it will be sequence of strings. My string with white space. Awesome. A to upper ASCII. Okay, just makes it all large. And echo B repeat 5. So number 4, repeat is also from string utils module. It repeats either a character or a whole string the requested amount of time. So if we would do copy it and just paste it here, right? If we run it, we have all that, but if we'll put, instead of a character, we'll just do a string like that and save it and run it. Yeah, we've got a whole string repeated. They didn't lie in the tutorial. Wow. To the users coming from other programming languages, especially Python, the way that imports work in NIM might seem wrong. If that's the case, this is the recommended reading. Okay, I'll read that later, I guess. Oh, look at that. Nice article about the topic. Cool. I'll evaluate it and see if it's worth talking about it on a stream. So then we have another example. Import math. So we import the math module. We have 30, for example, degrees, and C radians is C deg to rad. And that's converting degrees to radians. That's something that was built into math. And we have also sine, I don't know what to call it in English. And the other thing would be round. So sine takes radians. Okay. We round also from math module the result to at most 2 decimal places. Otherwise the result will be this ugly thing. Okay, so you round and to how many places? And okay, this is a good example to something to remember. So when we have this code here, right, we call sine of this. And then we call on it round. But nothing is stopping us from doing something else. Instead of doing that, we do round that number and then comma 2. And this should be exactly the same code. So that's the thing that I really like it. You can call it in a way that many programming languages are basically limited to, or at least you will need to declare 2 ways of calling things, which I did sometimes when writing my own code. I was frustrated. Why can't I call it? When I define something that way, I have to then do the other way around, and it's just painful. I like that, you know, hey, do whatever you want. Call it however you want. It's still the same code. Very much like it. Okay. Oh, math module also has the power operator for calculating powers of a number. Ah, look at that. So the whole module defines its own operator. That is, wow, super, very awesome. Okay. Creating your own. Oftentimes we have so much code in a project that it makes sense to split it into pieces that each does a certain thing. If you create 2 files side by side in a folder, let's call them first file name and second file name, you can import one from the other as module. So let's do the first file name. Okay. Go here, we'll create first file.nym and paste it. So we have plus and minus. Okay. And then here we have the little note. Notice how the plus procedure now has an asterisk. after its name. This tells nim that another file importing this one will be able to use this procedure. Oh, so it's basically declared as in JavaScript that will be an export. In other languages, it will be public, I guess, at least not private. Okay. By contrast, this will not be visible when importing this file. Okay. And then we have second file name. When we can import this, we'll go over this. Let's just create it. Second file.nim. And we paste it. Instant the error here with the minus. Minus doesn't have the asterisk. So here we import the first file, .nim. We don't need to put the .nim extension here. Yep, that's assumed. This will work fine and output 15 as it's declared in the first file and visible to us. Because it says a star. However, the number 3 will throw an error as the minus procedure is not visible since it doesn't have an asterisk. Okay, and just to make it, in case you have more than... Okay, let's get back to the code first. So if we wanted this to not be an error, of course, all we need to do is just put a star here, save, and that makes it, accessible outside of this file, and therefore it works here. Awesome. Or not. Minus. I think this might be just the... Oh, I saved it again, and again it freaked out. Let's try to run it. It works. I guess Visual Studio Code isn't happy about that. Oh well. I guess we'll fix that at some point. Okay. In case you have more than these two files, you might want to organize them in a subdirectory or more than one subdirectory with the following directory structure. So we have the main thing, my other subdirectory. So we have our subdirectory with a third file. My other subdirectory has fifth and fourth, while the main directory has the first and second. Okay, that makes sense. If you want to import all other files in your second file, this is how you do it. So we have the second file here. So we import the first file, and then the third file will be here. So we just do, my subdirectory / this. And for the other subdirectory, look at that. We just make an array of those so that we don't need to, repeat it so many times. Okay, that makes sense. Very simple. And it's interesting how you can have those spaces here. Cool. Guess it makes it readable nicely. Hey, this didn't even have any exercises. That's it when it comes to modules. All right. Not very exciting, but I guess there's a lot more to that topic that, over time matters. Okay, so let's see how much is when interacting with user input. Very little. Cool. So we can squeeze it in tonight. Because this is exciting. Finally, something will be happening. Using the stuff we've introduced so far, basic data types and containers, control flow, loops, allows us to make quite a few simple programs. In this chapter, we will learn how to make our programs more interactive. For that, we need an option to read data from a file or ask a user for an input. Perfect. Reading from a file. Let's say we have a text file called people.txt. In the same directory as our nim code, the contents of that file look like this. Okay, we have just 3 lines with 3 different names. We want to use the contents of that file in our program as a list sequence of names. Okay. So we can import the string utils and say let contents is literally read file people.txt. To read contents of files, we use the read file procedure, and we provide a path to the file from which to read. If the file is in the same directory as our nim program, providing a file name is enough. The result is a multi-line string. Okay, that is, I must say, that is extremely simple. Is it in string utils? I don't think so. Let people. Contents.split lines. And echo people, that's it. To split a multi-line string into a sequence of strings, each string containing all the contents of a single file, we use split lines from the string utils module. Hey, this is, wow. Basically 2 lines to do this stuff. I really like it. I'm surprised that we don't have to import anything to read a file. Okay. Yeah, we'll basically put the contents as a multi-line string and then return a sequence of each line. And here, yeah, I see. So look, here we have extra empty line, and here we have extra empty little thingy. So here, there was a final new line, empty last line in the original file, which is also present here. And here, because of the final new line, our sequence is longer than we expected or wanted. To solve this problem of a final new line, we can use the strip procedure from string utils. After we have read from a file, all this does is remove any so-called white space from the start and end of our string. White space is simply any character that makes some space, new lines, spaces, tabs, etc. So yeah, we just read the file and call strip on it. That's it. And we don't have that problem anymore. Very simple. Okay, that's it when it comes to reading files. Let's move to reading user input. Oh, I expected that part here to be much longer. If we want to interact with a user, we must be able to ask them for an input and then process it and use it. We need to read from a standard input, standard in, by passing standard in to the readline procedure. Okay. Excuse me. Echo, please enter your name. And then we do let name and we'll assign it a read line and provide a stdin, standard input. So the type of name is inferred to be a string. Okay. And then we just echo hello name. Let's try it out. Let's see if it works. Let's see if Visual Studio Code says issues. Let's just go here. We'll save it. Yep, it inferred a string. And we'll run it. Will it run or not? Oh, please enter your name. Ben. See? The code runner isn't that great. Let's run it again. Can't type in. That means we can go to terminal and do nim -r, and that'll be the hello.nim. Oh, nim. Enter our name, Ben. Enter. Hello, Ben. Nice to meet you. Awesome. That's simple. That is extremely simple. There are so many other programming languages that just completely overcomplicate it. I mean, there are reasons for making it more complicated, but I guess at this point here, there's no reason. And you could for sure make it probably a little more interesting on yourself if you dig deeper. Okay. if you're using an outdated version of VS Code, you cannot run this the usual way because output window doesn't allow user inputs. You need to run these examples in the terminal. The newer versions of VS Code, there is no such limitation. I have the newest version of VS Code, so... Okay, I guess they broke it again. Dealing with numbers. Reading from a file or from a user input always gives a string as a result. If we would like to use numbers, we need to convert strings to numbers. We again use the string utils module. Oh, I'm sorry, I'm yawning a lot. We again use the string utils module to use parse int to convert integers, or parse float to convert into float. So we have this, please enter your year of birth. The year of birth is, we read the line and we parse it as integer. Convert a string to an integer. Then written like this, we trust our user to give a valid integer. What will happen if user inputs 79 or 93? Try it yourself. Okay. Let age. Okay, you are that many years old. So it's a 6 years old tutorial. Why not? Something tells me few things changed in language since then. Probably minor things, but sure. So let's do 2024. And let's run it. Bam. Please enter your year of birth. I'll lie a little bit. Let's say some round number, right? Okay. So what if we're gonna give it none of your none of your business. There we go. Parse int. Invalid integer, none of our business. Okay, so just throw an exception or error. No, unhandle exception. So it's an exception. Okay. Cool. If we have the numbers txt in the same directory as our name code with the following content, and we want to read that file and find a sum and average of the numbers, provided we can do something like this. Yep, we can read the file, strip all the empty spaces, split it into lines, so we suddenly have, we import multiple modules, string utils given strip and strip lines, sequence utils gives map, and math gives sum. So we strip the final new line and split lines to create the sequence of strings. Then numbers is, okay. We take those numbers as strings and we map them where for each of them we're calling parse float, right? Map works by applying a procedure, in this case parse float, to each member of a container. In other words, we convert each string to a float, returning a new sequence of floats. Yep, so basically for each of those strings, it will call parse float. And then we do sum of the numbers, is we call the sum from the math. So this actually takes the whole sequence and sums the whole sequence. That's handy. And average is sums divided by a float of num length. Okay. Just calculate the average. Okay. Yeah, and of course this length is an integer, so we need to convert it to float first. Okay. Very cool. Simple. And I like to see the map. I wonder what else is in the sequence utilities. Exercises. Ask a user for their height and weight, calculate their BMI, report them the BMI value and category. BMI, the big joke. So out of date. So Let's do that. And we'll do everything from scratch. This way we'll learn something. Okay, so ask for the height. So we do echo. How tall are you? Right? Then we'll at some point do how heavy are you? I guess what's your weight? Whatever. And then we'll do convert strings to floats, because I will guess we'll be operating on floating values. Then we'll be calculate BMI, and there will be report the BMI value and the category. So it'll be something like echo your BMI is. We do BMI and you're in category. I'll just print category. Okay. We save it and now we'll be complaining about not having those. So let's see how do we do read line, right? So we do the let height, and this will be read line, and it will be std input, and we'll just do parse float, right? But parse float was in something like string utils, import string utils. Yes, I remember correctly. Awesome. And then we do the same thing with weight. Okay. So we should get those two numbers. We already converted them to float. We don't care about errors. We don't know how to handle errors yet. And then calculate their BMI. Mass by height squared. Okay. So mass divided by height squared. Let's just do kilograms and meters for now, because that's the simplest. So let BMI is weight, and we divide it by height times height. I guess we can do import math, and we'll just do by height and do this, right? That should be fine. Save it, and we have everything but the category. So the category is showing this thing. So that means that we need to get the case statement. Sure. Let's do the case statement. Category. Let category equals case BMI, and I don't remember off. Oh, now we can't do that because we're evaluating with larger, lesser, while case is only for simple things, so we can't do that. Okay, category will be error at first. Okay, so let's go from the largest to the smallest, or no, from smallest to largest. So if and we have the BMI is less than 16. Category is underweight. Severe thinness. Okay. Why do we have errors? How can it be assigned? Of course. Var. There we go. And then else if BMI is less than what? 17. Because notice that this is from 16 to 16.9. This is from 17. So, I guess this is from 17 to nearly 18 and a half. And we, in the first if statement, covered everything from here. That means that here we don't have to check anymore because this wasn't smaller. That means it's only larger or equal of 16. So that's how we can just continue up. So if BMI is larger than, below 17, category is underweight, moderate thinness. And then elif, and we can just copy this few more times, I presume, just so we don't have to do everything. So we have 17, then we go 18.5, and that will be mild thinness. Then we have normal range will be under 25. Then overweight, pre-obese will be under 30. Obese class 1 will be under 35. Class 2 will be under 40. All the round numbers. It's for sure is very real. And this will be an other case which is larger. So we just do else. Okay. We don't need the check anymore because it's larger than that. Larger or equal, we just go with that. All right. So that means we have the category, we can print it. And we can run it, right? Let's get rid of this and make it nice and large for us. So we run it. How tall are you? And this is in meters. So let's say I'm 1.75. Okay, that sounds decent. So it didn't error, that means it parsed. How heavy are you? In kilograms, I don't know, let's say I'm 100. Your BMI is 32.65, which is obese class 1. Look at that. Perfect. So that worked. If we'll go with some other crazy numbers, let's say 1.9. And let's say it's only 60 kilograms. You're very thin. Okay, makes sense. Okay, so that exercise is finished. And where did they go? Now we have another callouts conjecture exercise, repeated. So our program asks a user for a starting number. Print the resulting sequence. Okay, so let's do it quickly. Let's get to the thingy again. That was in loops. Was first pick a number and do all those things. Okay. And we get back down here. Exercises. Cool. That means that we can, in our code, we can actually do a little fun thing and declare procedure. Calculate the sequence. I don't remember the name. And we'll return something. I just want to add it here so that I can keep track of what needs to be done. Okay. So we've got that. What was the whole exercise? It was basically so program asks user for a starting number. So the exercise was that we need to print the whole thing, right? Pick an integer and create a loop, blah, blah, blah. It will print each step of the conjecture. Okay, that makes sense. That means in our exercise, we just print it, and that's it. So we can make it return a sequence of numbers, right? So it'll return a sequence of integers. Well, we need to give it the starting number, which will be an integer. And the rules were first pick a number. We did that. If it's odd, multiply it by 3. So this is where we basically need to do the whole thing. So we'll just define ourselves a variable, which will be numbers, and that will be a sequence of integers. Okay. Hey, we actually don't need to do that because we have that secret result variable that's already defined by that, and it's empty because it's initialized. Wow, this is super awesome. So what we have to do is basically result add that starting number. Okay. This way we start with that, and then we can do while result, and we do last of the result. Last element of the result is not 1, then we'll just continue with the loop. So if, and we do the odd. If let's get the let last number, that'll be their result. We'll just reuse that. So if last number mod 2 is 1, which is odd, then we basically do result dot add, and we will add it. What do we need to do? Multiply it by 3, so last number times 3 plus 1. So we just do it like this. And else, if it's not, we just divide it by 2. So we do result add, it'll be last number divided by 2. We already went through that. And we just keep going. So that's it. So let's just do the result add. I wonder if that will work with all those little things. Result add if this, we do that, else, and just do that. And it's not happy. result.add. There we go. It works. Wow, that's a short thing, and it already returns everything automatically. So we have the calculate. Then we can make another procedure. Print sequence. Oh, we don't need to. We don't worry about presentation right now. We already went over that once. So all we want to do here is ask the user, echo, pick a number. And magic. There you go. And then we basically get the let starting number. That'll be read line, standard input. And we want to do parse integer. So we need to do import string utils. There we go. So all we need to do now is let numbers equal, or we can just do echo calculate sequence, and we'll give it the starting number. Oh, we can't do that because we initialized this, and so we need to get full parentheses here, right? Or not. Oh, calculate sequence. There we go. So when we run it, without that, sorry, this won't work. Go to terminal, and we'll run it. Pick a number, 69. And there you go, the whole sequence. What was the number that was like large? 27. There you go. That's a large sequence. Cool. That works. And then we have one more exercise. Yep. Ask the user for a string they want to have reversed. Create a procedure which takes a string and returns a reversed version. For example, if user does this, returns that. Okay. Hint, use indexing and countdown. Yep, that's what I would do. So it just reverses a string, and that's it. So this will be really, really, really simple. We probably don't even... No, we need string utils to... No, we don't. Okay, so... a word, please. And we'll get the word to be just read the line. Okay. Just in case, we're gonna strip it so that it's nice and without all the spaces. And they want us to make a procedure for that. So procedure reverse, and that will be the text will be just string, and we return a string. So how can we do that? So we already have the return value, which is an empty string, and it's modifiable, so we can just use that. So what we could do is a for index in, and we do now count down. We want to count down from this will be the text length -1 to 0 by 1. And this way we'll get indexes, so we can basically get 1 and just put it in a string because we're going from the end to the newest. So result dot add, and we do the text index. And that should be it. And then we just do echo. And we do the word dot reverse. I really like the ways that we can just call all those however we want. It's just whatever makes sense, you call it that way. Here was made sense to be clear that we add this. No parentheses, no nothing. It's so nice. Here we call the strip. We could call it like that, but because there's nothing, we can skip it. And just so nice and simple. Sure, it gives you room for decision, and then if you're dealing with other people, you might have some arguments, but if you define some kind of standard and have common sense, and you can get some consensus with some other people, then hey, it's awesome. So a word, please. Let's do a fun word. Shenanigans. I guess that's how you write it. Exclamation mark. Enter. It worked. Okay. Hey, first try. I'm impressed with the language. It's really fun. It gives you that room to enjoy it, while it's still simple enough that, if somebody looks at the code, they won't have a headache. I'm sure you can make it look like a headache, but, if you have some brain, you can keep it simple, toned down, and yeah. Conclusion. It is time to conclude this tutorial. Hopefully this has been useful to you, and you managed to make your first steps in programming and/or the non-programming language. These have only been the basics, and we've only scratched the surface. But this should be enough to enable you to make simple programs and solve some simple tasks or puzzles. NIM has a lot more to offer, and hopefully you will continue to explore its possibilities. Okay, next steps. You can go with official NIM tutorial, NIM by example, there's Advent of Code, Project Euler. I don't like math. So let's just take a peek at official NIM tutorial and NIM by example. I must say that I roughly went through the NIM tutorial, part 1, and this one here is just, an eye-opener. It just teaches you so much more than the other one, but at the same time, it's like you need to notice things to understand. So that's very nice. The second part of it, because this goes through all the basics, roughly what we went through here, but goes a bit more of iterators, defining types, dealing with objects and such. Then part 2 is apart from syntax procedure programming. And this part is basically object-oriented programming, inheritance, recursive types, type conversions, all those things, dealing with exceptions, generics, which is really nice, and templates, which are also really, I really like templates. It's like metaprogramming, but without all the pains of it. And part 3 is metaprogramming, where I wouldn't venture even after reading those 2 parts probably. So that's one option that we could go through. And the other option is NIM by example. And I don't know how good that is, because, we had our hello world and all this stuff. We went through how to declare comments, variables. It's interesting that we already defined procedures here, but, it just demonstrates things. Mutable variables, all that. We went through it, so that's all good. And then we have already the consts, whatever, just, whatnot. we define the result that exists. We already learned that, so we can skip that. Typecasting and inference. So this is pretty much everything we already know. That's another thing. And then we have if else while. We already went through all this. Although what we haven't learned is this block thing. So I guess you can just mix around the blocks, and I think I know what it's about. But okay, this is concise. Case statement. Okay. And for loop and iterators. This is nice and concise. Procedures, operators, generic functions. Okay, you know what? Next stream we're gonna go through that quickly. Just, maybe not as fast as now, but we're gonna go through it quickly. And we'll see how much we know, and then maybe I'll just use ChatGPT or something to learn whatever we need at the very point. Because one thing is to read the manuals or whatever tutorials here and there, and okay, you do this and that way, but it's completely different when you want to set up your project. What is the good way to, set it up? In our case, we want to write a very simple library, whatever module that then we can publish and can be used by anyone. So that's yet another task on its own. So we might just be doing a little step by step. Let's figure out how to do this and that. We already learned how to read files. What about checking if they exist? What about listing directories? We already knew some loops and can iterate over things. It will be simple to make some recursive, and therefore we could, start doing some more fun. But for sure we'll need types because we want to be able to define our own stuff. And okay, this will include enums and distinct types. It will also aliases, which are awesome. It will talk about bit sets and files, which files will be, of course, awesome. JSON, maybe not that important here, but at some point. And more about string formatting, a little bit about object parent. Okay, this is going to be awesome. Even about channels and the concurrency. Oh, wow, this is... Okay, I'm excited. Okay, so that'll be next time. Yep, so that's the stream. I can tell you that tomorrow probably there will be a little separate video about setting up NIM on Linux, and I'll be chopping all those other streams up. I'll be busy this weekend, especially on Sunday, but next Monday for sure there'll be next stream where we can hopefully go through this whole tutorial, maybe a little fast pace. Let me know if you prefer fast pace or slow pace. I have very little viewers right now, especially of this stream. But if you actually survive to that far into the stream, hey, let me know, or leave the comment on YouTube afterwards if you watching at some point. Any kind of feedback is awesome. So that's it. I wish everyone to have an amazing weekend. And, I'll see you on Monday.